Welcome dear viewers, Shoaib and Dayo is here with another lecture of the electrical machines, and today we will discuss the compound wound generator. In the previous videos we have discussed the types of the self-excited DC generator, in which we have covered the DC series generator and also the DC shunt wound generator, and this compound wound generator is another type of the self-excited DC generator. So in a compound wound generator there are the two sets of the field winding connected on the each pole. So one is connected in series with the armature and second is connected in the parallel with the armature. Recall the concepts of the construction of the DC machine. So there are the two main essential parts of the DC machine, the field system and the armature. The field system is provide the necessary magnetic field within the armature is rotates, and the armature winding in which the working EMF is produced. Either in the case of the generator, the generated EMF is produced, or in the case of the motor, DC motor, the back EMF is produced. So let us discuss the compound wound generator. So first of all, in a compound generator there are two sets of field windings on each pole. So one is connected in series with the armature and other is connected in parallel with armature. So in a compound wound generator there are the two sets of the field winding on the each pole. So one is connected in series with the armature, so field winding is connected in series with the armature, and other set of the field winding is connected in parallel with the armature. So there are the two types of the compound wound generator. So first type of the compound wound generator is the short shunt compound generator, okay, and second is the long shunt compound generator. So first of all we are going to discuss the short shunt compound wound generator, okay. Now the short shunt compound wound generator can be defined as in which the field winding is connected in parallel with armature winding. The field winding is connected in parallel with the armature winding. So first of all we need to draw the circuit diagram of the short shunt compound wound generator, and after discuss the diagram we will drive some or write some mathematical formulas related to the short shunt compound wound generator. So let us draw the circuit diagram. Now, in which the field winding is connected in parallel with the armature winding. So, this is the field winding and this is the armature winding, and this is the series winding connected with this load. So, this is the load, okay. These are the carbon bushes, positive and negative. This is the armature in which the Eg is produced and also Ia is produced. So, this is the direction of the armature current. Ra represents here the resistance of the armature. Here this is the field winding. So, here R shunt is represented as the resistance of the shunt field winding, and here this is the resistance of the series field winding, and this is the load where we will get the terminal voltage V. Now here the armature, this is the armature current, is divided into the two parts. This is the I shunt, and here this is also the IaC, which is equal to that here the IL, because here you can see the series field winding is connected in series with the load. So, this is also the direction of the current, and this is also the direction of the current towards the armature terminals. So, you can see this is the circuit diagram of a short shunt compound wound generator, in which the shunt winding, and this is the shunt winding and this is the armature winding. So, in the short shunt compound wound generator, okay, the field winding is connected in parallel with the armature winding, as you can see the diagram. Now, let us write some equation formulas related to the circuit diagram of a short shunt compound wound generator. So, first of all, if we are going to calculate the load current, so here first is that the series field, okay, first is the here the series field current, which is denoted as the ISE, okay. So, you can see the series field current is equal to the load current, because this is connected in series with the load side. So, here ISE is equal to IL in the case of the short shunt compound wound generator. Number second is the shunt field current. Now, the shunt field current, here you can see this is the shunt field current. Now, the shunt field current is equal to the terminal voltage plus IAC RAC. So, this side divided by the resistance of the shunt field winding. So, this is the resistance of the shunt field winding. Number third is the terminal voltage. So, terminal voltage is equal to the V, okay, This is equal to the V. So terminal voltage where we are getting the generated EMF which is produced by the compound wound generator. Now in the case of the, now here this is the case of the short shunt compound wound generator where we are getting the terminal voltage at the load side. So this can be written as Eg, okay, minus IaRa minus IaRa, resistance of the armature we have considered, and also the Ise Rse, okay. So this is the terminal voltage. Number 4th is the power developed in the armature. So as we know, the power is the product of the voltage multiplied by the current. So here power developed in the armature. So here the generated EMF is produced in the armature, so which is the Eg multiplied by this current of the armature. So this is the power developed in the armature, which is the product of the generated voltage multiplied by the armature current. So 5th point is the power delivered to the load. So power delivered to the load is the product, the power delivered to the load is the product of the terminal voltage multiplied by the load current. So this is the product of the terminal voltage multiplied by the load current. So these are the mathematical formulas related to the short shunt compound wound generator. So again I am going to repeat this, that the short shunt compound wound generator is the type of the self excited DC generator in which the field winding is connected in parallel across the armature winding, okay. So here we have calculated or write some mathematical formulas related to the short shunt compound wound generator. So in a short shunt compound wound generator, as you can see, this is the shunt field winding and this is the armature winding, and both are connected in parallel to each other. So this was the short shunt compound wound generator. Now let us discuss the long shunt compound generator, which is another type of the compound wound generator. Now in the long shunt compound wound generator, now the shunt field winding is connected in parallel with the both series field winding and the armature winding. So let us discuss this long shunt compound wound generator. Now in a long shunt compound generator, the shunt field winding is connected in parallel with series field winding, with the series field and armature winding. So let us draw the circuit diagram of the long shunt compound wound generator. So this is the shunt field winding having the higher number of the turns of the wire to produce the necessary amount of the MMF, having the high resistance, okay. And here this is the series field which is connected in series with the armature of the long shunt compound wound generator. So these are the carbon bushes, as you can see, and this is the load, okay, which is connected with the okay. Now this is the load which is connected with the armature terminals, okay. Now this is the shunt field winding. So here R shunt is the resistance of the shunt field winding, and this is the armature in which the generated EMF is produced, and here in the armature current is produced, and also we are denoting the resistance of the armature as the Ra over here, okay. Now this is the series field. So here this is the series field winding resistance, okay, which is denoted as the Rse, and this is the armature current which is produced by in the armature, okay, and here this current is divided into the two parts. Now this current is towards the shunt field winding, so that is called as the I shunt, and this current is towards the load side, so this is called as the I load. And at the load side we are getting the terminal voltage generated by the long shunt compound wound generator, okay, and these are the direction of the current flow towards the armature negative terminals. So as you can see, this is the shunt field winding, okay, and this is the series field, and this is the armature, okay. Now as you can see, the definition which we have written on the top of this circuit diagram, which is in the long shunt compound wound generator. So this shunt field winding is connected in parallel with the series field and the armature winding of the DC compound generator. Now let's write some mathematical formulas related to the long shunt compound wound generator. So number first is the series field current. Number first is the series field current. Now as you can see the diagram, this is the series field winding and this is the armature, both are connected in series to each other. Now here in this case the IAC current in the series field winding is equal to the current in the armature. Now this armature and the series field winding current is divided into the two parts. The first current which is moved towards the load, so that will be called as the load side current, and the second current which is moved towards the shunt field winding, so that current is called as the shunt field current. So this is the sum of the, so here in the case of the series field current which is equal to the armature current, so here in the case of the long shunt compound wound generator, the series field current is equal to the armature current, and it can be defined as it is the sum of the load current plus I shunt current. So armature current in the case of the long shunt compound wound generator is the sum of the shunt field current and also the load current, okay. Second is the shunt field current. Second is the shunt field current. Now the shunt field current, as you can see, this is the shunt field current, so it's very simple. According to Ohm's law, I is equal to V over R. So here I shunt is equal to terminal voltage generated by the long shunt compound wound generator divided by the resistance of the shunt field winding. So I shunt is equal to V over R shunt, okay. Number third is the terminal voltage. Now terminal voltage in the case of the long shunt compound wound generator is the V is equal to Eg minus Ia, okay. Now here we are considered the resistance of the armature and resistance of the series field winding, okay. So this is the terminal voltage, which is the Eg minus Ia, and both combination of the armature resistance, and also we are going to consider the resistance of the series field winding. And number fourth is the power developed in the armature. So simple, the power developed in the armature is equal to the generated EMF produced in the armature multiplied by the current which is produced in the armature. So the power in a developed in an armature is the product of the generated voltage multiplied by the armature current. Number fifth is the power delivered to the load. So power delivered to the load, so as you can see the Eg, okay, Eg Ia minus I square Ra plus Rse, okay. Now here taking I as a common, so Ia is equal to Eg minus Ia and the resistance of the armature plus resistance of the series field winding. So as you can see, this is equal to the terminal voltage Eg minus Ia, and consider the both resistance of the armature and the resistance of the series field winding. So this expression is equal to the terminal voltage. So power delivered to the load is equal to V multiplied by the Ia, okay, and where, so or V multiplied by Ia or V IL. So power delivered to the load is equal to the terminal voltage multiplied by the load current. So this was the long shunt compound wound generator. So if I am going to summarize the lecture at the end, so this was the lecture regarding the compound wound generator. So in a compound wound generator there are the two sets of the field winding, one is connected in series with the armature and second one is connected in parallel with the armature, and there are the two types of the compound wound generator. Number first is the long shunt compound wound generator, second is the short shunt compound wound generator. So in a short shunt compound wound generator, the shunt field winding is connected in parallel with the armature winding, as you can see the diagram of the short shunt compound wound generator, and also we have write some mathematical formulas related to the short shunt compound wound generator, and the long shunt compound wound generator can be defined as the shunt field winding is connected in parallel with the combination of the series field winding and both the armature winding. So also we have write some formulas related to the long shunt compound wound generator. This was the lecture. I hope that you have understand the today's lecture, and this lecture is very informative for you all. At the end, do subscribe my YouTube channel Shoaib Ahmed Dayo for more informative videos related to the electrical engineering area. Thank you.